Welcome back to Cloud 42, I'm James. Today we're going to be building a tool for picking up angled edges in the mill. This is an idea that I first saw in a video by Stefan Güterswinter. I highly recommend you go check out his video. There's a link down in the description. And as you'll see, when making this tool, there's a couple of measuring challenges to be able to measure as it's being cut. Stefan used a disc micrometer when he made his, and I don't have one of those, so I'm going to use a different method using gauge blocks. Let's go over to the computer and take a look. This is the tool that we're going to make. Now, this is just a cylinder. This is 3/4 of an inch in diameter and 3/4 of an inch long. And it's been bored out in the middle to provide relief, and then a section of material has been milled out. And the way this is done, it's milled very precisely so that this surface intersects with the center of the cylinder, and this surface is at exactly 90 degrees to it, and it also intersects perfectly with the center of the cylinder. And the accuracy of the tool is entirely dependent on how accurately these surfaces can be machined, so that the distance between this plane and the opposite edge of the cylinder is exactly half the diameter of the cylinder. In this case, it's 3/4 of an inch in diameter, so that's 3/8 of an inch. What is this used for? Well, let's take a look at an example. This is a part that I need to locate in the mill for machining. This is actually a fixture for making some clamping jaws. But the way it works is I have a rectangular piece that's set in the mill vise at a 45-degree angle, and I want the origin to be set on this corner of the workpiece. So if I'm using an ordinary edge finder, or even a Heimer, it's relatively easy to locate this face. So I can locate the Y0 very easily by just running the tool up against the back side of this. But how do I locate the top point, the X0, and how do I locate the Z0? There are several ways you could do it. You could put a pointed tool in the chuck and bring that down and touch it, but this is exactly the kind of situation that this edge finding tool is for. If I bring this tool and just set it on top of the workpiece in the vise, it doesn't really matter if this is a 45-degree angle. As long as this is a right angle that the tool is sitting on, then I know that the top edge of the stock is exactly in the center of that cylinder. So then I can bring an edge finder against this side, and when it kicks out or zeroes against the side of the cylinder, I can then subtract half the diameter of the cylinder, because I know that this edge is exactly 375 thousandths from that corner. And it also works vertically. If I come down and touch off or use a shim, I usually use like a 10 thou copper shim underneath the tool, or even the tip of the edge finder to locate the top, then I know that once I find that Z contact point, the actual edge I'm looking for is exactly 375 thousandths down below that. Here's another example of a setup. Ultimately, what this fixture is for making these Talon grip clones. They're a low profile clamp jaws. And this is very small, so this is 1/4 of an inch thick. So this feature that I need to mill here on the side of it is actually very small and very shallow. There's just not really any way I'm going to get in there with a round nose end mill or a profile tool to do this. But if you rotate this up 45 degrees, you can do this with a 30 thousandths corner radius end mill. And so that's what this fixture is for. This is a setup to mill that feature in the side of the jaw. So you see you've got a vertical side and a horizontal side. But we have exactly the same situation here, where once the stock's clamped in, because these features are so tiny, I could try to mill the jig, the setup jig precisely, and just try to make sure that I can position off of it, though of course, it could be positioned off the floor of the vise down here if everything was exactly perfect. Or it could be taken off of one of these corners. You have the same problem though. You need to find and locate an edge that's at a 45-degree angle. And so you can do exactly the same thing with this tool. Drop it on here. You can locate this end of the part or the end of the fixture with the edge finder. And then you can do the same thing. Run the edge finder against either the front or the back side of this and then add or subtract 375 thousandths. Then you can find the top by locating on the top of the cylinder and subtracting 375 thousandths. Now in this case it'll be a square edge before it's milled, but even if it weren't a square edge, this is another example where you can actually use this tool to locate this point where there isn't any material. It's the intersection of these surfaces if they were there, but even after the material's removed, you can still throw this tool on the top and recover that zero. So that's how it's used, and that's how I plan to use it. I should probably apologize. You were probably expecting that I was going to be continuing on the tool post grinder series. We're in a little bit of a recursive loop here, where I'm working on the tool post grinder and then I'm trying to work on the motor clamp, and the motor clamp doesn't have any parallel sides, so I made some soft jaws first. And so I can mill off the material after I flip that. But in order to hold the block, I really wanted to have some talon jaws in order to do that, and I figured, well, I can make those in the shop, and so that's what this project is. And then in order to accurately machine the jaws for the low profile clamps, then I need a way to locate edges at a 45-degree angle, so now we're making this tool. So we will get back to the tool post grinder. That's still on the back burner. We're just getting some tools made that we'll need so that we can complete that project. Let's go and get started. Okay, the tool is going to be made from 3/4 inch drill rod, and it's going to be 3/4 of an inch long. So I need to cut some pieces that are just a little bit longer than that. So I'm going to put a mark right here at 7/8, which should make it easy for me to make multiple cuts without measuring. This is, again, this is 3/4 inch W1 drill rod. Get a good grip on that. This stuff is pretty tough, so I think I'm going to slow the saw down. Okay, I've slowed the saw down to 80 feet per minute, which is slower than needed, but at least we won't burn up the blade. Okay, that looks good. Now we'll do one more. Okay, the first step is to just face these parts to length. Try to get them as straight as possible on the chuck. And I'm going to use carbide for this. Now I've got the lathe spinning right now, even though this is W1, I've got it spinning at 2400 RPM, which still won't quite reach the recommended 500 to 600 surface feet per minute since it's only a 3/4 inch diameter part. But we will just start cutting and see how it goes. That is a lot stringier than I like, and the surface finish is not awesome. Let me try pushing it just a little bit harder with a greater depth of feed. Yeah, that's a little bit better. Going to put a tiny chamfer on the end. A little bit more than that. Not really trying to put much on the end here. I'm just trying to make it so it's not sharp. Okay, that's great. Let me do the other one just like it. So I'm doing 2 here. Nice, but didn't quite clean up. Looks good. Now I gotta flip it around and face it to length. And to do that, I'm gonna put a parallel in here so that I'll have a repeatable depth. I've talked before about how I don't really like doing this, but I don't have a thin enough faceplate for this or spider for this. Okay, that way when I put the other one in, it'll be the same depth and I can use the same reading on the dial indicator for length. Great, now let's measure the length. And I'm not quite sure if I'm going to be able to do it this way. Nope. Let me grab see if I can get a micrometer in there. And there's also a nope. Okay, this puts us back to depth mic. Now I'm going to measure off of the face of the chuck. And looks like we've got 3.0, so it's 1.309. And we know that we had a 1/2 inch parallel here. Which means we're at 809, which means we need to take another 59 thousandths. So let me come back here on the dial indicator. I know I was at 30, so another 59 thousandths from that, 10, 20, 30, 40, 59. And I will just go ahead and rotate my 0 to there. Make sure it's the first 0. Sorry, I got chips under here. And that will be my target. And when we get a little closer, I'll measure again and just make sure. Okay, should be left now with 20 to go. And that looks like that's exactly right. 20 to go. And 20 seems to be a pretty decent cut with the carbide in this stuff, so take it right to the 0. And we'll put a little chamfer on it. Okay. We're going to do the other one the same size, but I'm going to go ahead and measure and see just how close we actually got. Should be 3/4 of an inch. 747, 747, 747. That looks good to me. Let's do the other one the same size. $7.55. Must have had a problem with the 0. Oh, you know what? I got a chip right there. And there's one on the other side too. Chips under the parallel. That will make a big difference. There, that's flush. Once again, and I wonder how I get chips on my parallels. Okay, so let's see. If we come right to 0 on the dial, we should take about 5 thousandths if it's still in the right position. Nope, looks like it was just off. Okay, let's take 5 then. Oh, that's a very nice surface finish. Note to self, just take 5 on the last pass. See where we are on length now. 750.8, 751, 751. So we're about 751 on this one. Okay, let me put the chamfer on it. Okay, that's beautiful. Wow, that end is so beautiful. I think I'm going to take both of these down slightly undersized just so I can have that finish on both ends. And watch me not drop the parallel this time. And let's do the same thing with the other one. I don't want to do both ends, I'll just do the one that's the roughest. Let's see where we are on length. 745 almost exactly. .45. Just a tenth over. Get my finger out of the way here. I think I got something in there. Yeah, 745 too. Well, that's interesting. Oh, that's beautiful. And the other one, a couple tenths under 745. I can live with both of those. Okay, now, next step, we gotta drill a hole through it. Now the hole doesn't have to be precise. The only purpose of the hole is just to provide clearance for when we cut out the notch. Grab a drill chuck here. Okay, let me grab a drill. Okay, I'm going to slow this down considerably, just because these are high-speed steel drills. This is pretty tough steel. Let's just go down to 720, and that's probably not really, that's probably further than we need to go, but going a little slower on the drilling operation won't hurt anything. It'll help prevent shatter. Okay, so the first thing we're going to do is use a center drill, and we're just using this to spot. See if I can get this position where I won't have to move it back and forth. Here's our spot. Now we're going to drill this out about 1/8 of an inch. This drill's actually just a little bit smaller. And I guessed wrong. Okay, and that's through. Okay, looks great. Then we'll do the other one just like it. And we're through. You know, I have a reamer. It'll make the inside of this hole pretty, and I think I'm going to use it. First, I'm going to take the speed way down here. So I'm taking it all the way down to 150 RPM, but that's overkill. It doesn't need to go that slow, but it'll be nice and safe. And let me find my 1/8 inch reamer. There it is. Through. As I said, this is completely unnecessary, but that bore is going to be exposed later, and this will make it look nicer. And we'll just use this little Noga rotary countersink. And give us a nice little countersink on the edge. Very nice. Not very much, just enough that it's not sharp. Perfect. Those parts are now ready for the mill. Okay, we've got 2 of these, and we need to mill out 1/4 of the material on these. And we need to get them square in the vise so that that'll be square in the final part. So I'm going to use 1 parallel. I don't want to mess around with anything that could push it out of square. I want the back jaw of the vise to do all of the positioning of the part. So I'll just set it in on top of that 1 parallel. And I'm going to use the other one, which is our backup part, as a packing block on the other side of the vise. Grab the vise handle here. Now I'm not going to do anything but just clamp these lightly. I'm going to clamp and release a few times and just let them settle into position. The vise jaws are very hard and the parts are hard, and so this should square them up. And I'll give them a nice snug because we're going to be removing a lot of material. Now those should be secure and they should be straight. But I don't want to trust should be. I'm going to get a dial indicator and find out if they really are straight. Okay, we're using a 3/8 inch powdered metal rougher. This is pretty tough steel, and the powdered metal rougher will be very durable in this material. And we're also going to run some coolant here. This is soluble oil. Let's see if we can get this lined up for the cut. Trying to destroy the cutter in the process. So I definitely want to stay above the center line of the hole. And I want to stay to the right of the center line as well. I'm just lining this up by eye. Okay, that should definitely put us in a safe position. So I'm going to zero my x-axis. Now, how much of a cut can this thing take? Half the diameter. So we should only be taking, in this case, a 3/8 inch diameter. So we should only take about 3/16. So and move it to the right. 1.875, and let's run this thing up and take a little cut and see how it does. Take another 100 thousandths. And another 100 thousandths. It still looks like we're in the right position. Now, let's see what we got here. Oh yeah. That's pretty nice. It looks like we're totally in the right place. Now I want to go ahead and take a roughing cut on this other one as well. Okay. That is very nice. We've got two of these roughed out. They're under half, and we're all the way to the center hole on both of them. So I think that is going to work. Actually, I am very, very pleased with the finish on that. I'm very pleased with the performance of that roughing end mill. Obviously, this side of it is a little bit coarse, but the bottom is beautiful. Very nice. Okay. Let me swap this out. I'm going to go to a 1/4 inch carbide straight flute end mill, and we're going to use that for the final finish on both of these. Okay, so I have this set up. I've got it in the center, got it leveled, and I have a 1/4 inch carbide end mill in here. And what I'm going to do is I need to face these sides and get them to final dimensions. Now, to measure this, it would be really convenient if I had a disc micrometer, which I don't, but I do have gauge blocks. And so the overall width of this is 3/4 of an inch, and the notch needs to be 0.375, then 3/8 of an inch in from both sides. So what I can do is put a stack of gauge blocks in here and measure vertically across the gauge blocks and horizontally across the gauge blocks to make sure that I'm in the right position. So I think I'm going to start with getting the floor of this to dimension first. So I'll bring the cutter 5 thousandths off the sidewall. And I will drop it 5 thou, and just take a cleanup cut on the bottom there and see, and then we'll measure and see where we are. Okay, let's get the tool up out of the way. Z5. Now let's clean this up and see where we are. Since we're going to be measuring across the bottom, I got to get everything out from underneath it as well. And it's wet down there from the coolant. Just running soluble oil. Okay, we'll grab some gauge blocks. Okay, this is the gauge block stack, and it is a 400 thousandths block and a 100 thousandths block. And the 100 thousandths block is offset, and the reason for that is so that it can overlap the top of what I'm trying to measure here. Make sure those are seating well. And now when I measure vertically, I'm going to have 375 plus 500, so I'm going for a target dimension of 875. Let's see where we are right now. $895.3. Whoops, just broke the ring between the blocks. I'm trying to be very careful to hold these flat and down on the bottom and not riding on any burrs. $895.5, $895.4, $895.5, $895.4. Now I'm going to clean it up, redo the setup, re-ring the blocks, and measure it again. $895.3, $895.3, $895.35, $895.3. Okay, so let's call it $895.3. And I'm ultimately trying to go to 0.875, which means I need to drop it 20 thou. I'm going to drop it 15 thou and take another cut. So I'm going to take my Z down to minus 0.020 because I was already at minus 5 thousandths. I'm going to go down another 15, take me to 20 thousandths. And then we'll take another cut and see where that leaves us. So bring the Z back down. Now slowly go down to to z minus 0.020. Five thou off the wall. Look at it and make sure that makes sense. It does make sense. Let's take another cut. Eight 80.3, 880.3, 880.3. Okay, I believe that. So what that means is we need to take 5.3 thousandths off of this. So we need to go to a z of minus 0.0253. So let's do that. Wrap it down to z0. Z minus 0.0253. Go back over to 5 thou off the wall and X, and take our last cut for the vertical, for the top of this. $875.3, $875.2. Okay, I am totally happy with that. Now, let's see where we are horizontally. Figure out how to get my hands on this. Yeah, that's not going to work. It's going to have to be done blind. Oh, you know what? This micrometer is not going to work. That's fine. We can grab another one. This one will. Looks like about 891. So I got about 891.5. Okay. Bring back the gauge blocks and see what we are going to have. So we actually should have had this should come out to exactly 880, and there should be 5 thou left. And that is dead on 880. Let me re-ring this and take a couple more measurements just to make sure it's not just what I wanted to see and it's actually what it really is. Nope, it's just 880. Which means we need to take 5 thousandths more. Okay, that should put us right at 0.875. Let's see if it really did. Look at that, dead on. And of course I moved it. .875. Look at that. Okay, let's take it out of the vise and have a little closer look. That's it. It needs a little bit of deburring, and then it's done. Okay, there's just one more step, and that's to engrave the maker's mark on the tool. Looks nice. Let me stone off those burrs and take it over to the bench and take a look. Let's see how close we got. This is the tool is 3/4 of an inch in diameter, and it should be split exactly in half, which means that from either flat surface to the opposite tangent edge of the cylinder should be exactly 3/8 of an inch. Well, how do we measure that? Gauge blocks. So this is a tenths indicator that I have set up. I have a 0.400 gauge block here. That's not important. It just has to be larger than 375 so that I can rest this on top of it without it hitting the bench. And now I have an 1/8 inch gauge block and a 1/4 inch gauge block rung together. So this is exactly 3/8 of an inch. So I'll take this 0.400 plus the 3/8 on top and make sure that the dial indicator is zeroed. Again, this is a tenths indicator, so each large number is 1/1000th of an inch. So you can see that is just right on 0. So now if we take that away and we bring this in and put the surface down against the block, this should, at the highest point, read 0 on the indicator if it's exactly 0.375 inches from the face to the tangent edge. Let's see how we did. And that, I'm going to say, is close enough. It's pretty much dead on. I really can't see any difference between that and the reading with the gauge block. Let's try the other side. Looks like we're about 2/10,000ths of an inch under, which is beautiful. Maybe just a little bit less than 2/10. That is close enough. In fact, that's way better than I anticipated with the little tools that I have. That's it for today. Give me a thumbs up if you like what you're seeing. Feel free to leave a comment and be sure to subscribe so you won't miss future videos. Thank you for watching.